All right, so for today's lesson, we're going to go through some of the properties of a quadratic function, and we can kind of identify a quadratic function just by looking at the graph itself, okay? So typically a quadratic function, it's either going to be up like this, it's in the shape of a parabola, okay? When we have a positive coefficient, when we have a positive a, remember, yeah, it's spacing up, right? So we have ax squared plus bx plus c, okay? If this is positive, we have a parabola that opens up, okay? If it is negative, we will have a sad parabola that points down, okay? Remember, we have like an axis of symmetry in these. We will have either a maximum or a minimum, depending on whether it opens up or opens down, okay? Yeah, so that's just a couple quick ways that we can know we have a quadratic function just by looking at the graph itself, okay? So we can also find out if we have a quadratic function by looking at just the equation or the function itself. Okay, so remember, quadratic functions have a degree of 2, right? So quadratic functions have a degree of 2, okay? So in this 1a, y is equal to negative 8x minus 3. What is the degree on this function?
Oh, it'd just be 1.
Just a 1, right? Yeah. If we don't see an exponent on our variable, we just assume that it's 1. So this is a first degree function, therefore not quadratic. Okay, going down to b, I see we have a degree of 2 right there, and there's not a higher exponent throughout, right? So is it quadratic?
Yeah.
Yeah. So degree of 2, therefore it is quadratic. Okay, moving on to c. So y is equal to negative 4x cubed minus 8x squared minus 3. So what's the degree of this function?
3.
3, right? So right here, we have an exponent of 3. So the highest exponent tells us the degree of the function, okay? So this function has a degree of 3, therefore not quadratic. Okay? Perfect. So moving on down, we have a factored function here, okay? So yes, we only have degrees of 1 on our x's, right? But if we were to unfactor it, okay, if we distributed our x back into the brackets, we would have y is equal to x squared minus 6x, right? So what is the degree on this function? 2, right? So therefore it is quadratic, right? Okay, and this last one here is kind of similar to the last one. We only have a degree of 1 on there, right? But we are squaring that bracket, right? So if we wanted to expand that, which we can, it would become a quadratic, right? So this will become x plus 4, x plus 4. That's just expanding that x plus 4 in the brackets, right? Minus 50. If we use our FOIL rule, remember first, outside, inside, last, we can expand these brackets here. First, outside, and then inside, and the last. So we still have that 3. And then x multiplied by x gives us x squared, right? So right there, we should know that it's a quadratic if we have a x squared, right? So x squared plus 4x plus 4x again plus 16 minus 50. Okay, we could stop right there because we're just asked, is this function a quadratic? We have the highest degree is 2, so therefore it is a quadratic. Okay. Now, for each of the functions that are quadratic, we want to determine if the parabola opens up or down, and also what the y-intercept is. Okay. So if we jump up to the top here, we'll start down here at our first quadratic. So remember our general equation for quadratic: ax squared plus bx plus c. Okay, whatever a is, so if a is positive, what does our quadratic do?
Oh, it goes up.
Opens up, right? So if a is positive, it opens up, so a happy quadratic, right? If a is negative, it's sad parabola, right? So it opens down. Okay, so in this case, it's written in a different form than our ax squared plus bx plus c. So we can just rewrite that. So generally, we always want to put the highest exponent first and have it like descending from there. Okay, so we can just rearrange this. So y is equal to negative 6x squared plus 2x, right? This is positive, so we're just going to say it's plus. And then plus 7 is last. Okay? Now, we need to look at our a. It is negative, right? So is it a happy parabola or sad parabola? Sad parabola, right? So this one will open down. And what about our y-intercept?
It's 7.
It is 7, right? So it's going to be the c in this form. So this tells us our y-intercept there. Okay? So if our c in this one is 7, then our y-intercept is 7. Okay? All good for that one? Yeah, perfect. C is not quadratic, so we don't have to, which is excellent. Now we're on to D. Okay, so let's look at our x squared. Is it positive or negative?
Oh, it's positive.
Positive. So we're going to have a happy parabola or a sad parabola?
Happy.
Happy parabola, right? So it opens up. And what about this one here? We actually don't have our ax squared plus bx plus c, right? But in this case, because there's nothing there, we can just assume that it is 0, right? If it's not there, okay? We could also, opens up and y int equals 0. When we are also solving for the y-intercept, it's might be easiest to set our x equal to 0 and solve it that way. So let's do that as well. So y is equal to 0 squared minus 6 times 0. 0 squared is
0.
0, and 6 times 0
0.
is 0. So that equals 0. Right? So y-intercept is 0. That's just kind of proving that, right? Okay, and our last one here, 3 times x plus 4 squared minus 50. We said this one is quadratic.
Yeah.
Okay, so we need to expand that to see what the coefficient on our a is, right? So we are almost there. So if we just finished distributing this in, so I could simplify that a little bit. So we agree this is quadratic, right? So I'm just gonna clean up these terms because they are like terms, right? So we should always simplify our like terms when we can. Okay, so I have x squared, so plus 4x is equal to 8x, very good. Okay, and then we're gonna leave that 16 alone, and then minus 50, okay? Now, we also need to distribute this 3 in. Okay, so we'll have 3x squared plus 24x. 16 times 3 is 48. And then minus 50.
So minus 2.
Yeah, perfect. So 3x squared. So we'll simplify again because these are common terms. 3x squared plus 24x minus 2. So our y-intercept will be right there. And our a is right here. So if we have a positive a, we have a happy parabola, right? So opens up. And our y-intercept is right here, negative 2. Okay. Perfect. How do we feel about that stuff? Pretty good? Yeah? Cool. Well, let's continue to get into our quadratic function. So I handed you guys out these notes. Did I? No, I was getting there. There we go. I just got distracted. As I said earlier, I'm easily distracted. That's okay. I just noticed a lot of things that way. Okay, so this is probably going to be a 2-day lesson, which is totally fine. And again, we're just going to continue to get familiar with the anatomy of quadratics, okay? So a review, we're going to label this quadratic here, so please take a moment to label that. Okay, so let's start with the vertex. We'll just work our way up top to bottom. Okay, so what is the vertex? Yeah.
It's where the parabola curves at the very bottom.
Yeah, perfect.
Lowest or the highest point.
Lowest or our highest point, right? Depending if it opens up or opens down. Yeah, you're absolutely right. Really good. So right here, this is going to be our vertex. And in this case, is it a maximum value or a minimum value?
Minimum.
Minimum, right? So let's just cross off maximum and minimum. And again, for that is because this is the absolute lowest point of this parabola. Everything else is greater than that vertex. Okay? Perfect. So we said it's a minimum. Good, and we label our vertex. Excellent. So next is our x-intercepts. Our x-intercepts. So what are we crossing here? The x-axis or the y-axis? For our x-intercepts. Just for our x-intercepts.
Oh, we'd be crossing. Like, what do you mean?
Does it cross the x-axis? Like when we're doing the x-intercepts?
Yeah.
We're asked, when we're finding the x-intercepts, we're finding where it crosses the x-axis, is what I'm trying to say. So this is the x-axis, right? Yeah. So for our x-intercepts, we want to know the points that it does cross the x-axis, right? So right here, it's pretty much, it's close enough to 1, right? Yeah, so there's 1 x-intercept. So let's put in our ordered pair there. So anytime we do an ordered pair, so we go x and then y, right? X first and then y. So what is our value of x for our first intercept? 1, right?
Oh, yeah.
1 to the right. And our coordinate for our y value is 0, right? It's right on that x-axis. Anytime at the x-axis, your y equals 0. Okay, so our first x-intercept is 1, 0. And our second one is 2, 3, 4, 5, 6. Let's say 7. Yeah, 7.5. Yeah, sure. We'll say it's 7.5. So our second one is 7.5 and 0. Okay? So again, those are what crosses the x-intercept or the x-axis. Okay? So next is our y-intercept. So that is where it crosses the y-axis. So remember, y is a little bit taller. So right there, yeah, about 3. So remember, it goes x first and then y. So our x value of our y-intercept is always going to be 0. Okay? Always going to be 0. So 0 for the x, and then our y is 3 up. So our y-intercept is 0 and 3. Okay, so the axis of symmetry. I guess we should give us an ordered pair for our vertex too, okay? So our vertex here, we got 1, 2, 3, 4, 5, let's say 6 down.
4 across.
And 1, 2, yeah, perfect. So 4 across and 6 down. So make sure that's a -6, right? Because we're going down. So we'll just say 4 and -6. Okay, so that must mean our axis of symmetry is along that vertex. So what is our x value for our axis of symmetry?
5 and 0.
1, 2, 3, 4.
Oh, 4.
Yeah, so the axis of symmetry will have the same x coordinate as the vertex. Okay? So axis of symmetry, this one, x is equal to 4, is what we'll say for that. Okay, and again, the axis of symmetry will have the same x coordinate as the vertex. Okay? All good for that one? Yeah, perfect. Okay, so you guys try this one on your own, please. So now we're going to use our calculator to find our points of interest. Okay, so if you do the second trace feature in calc, you can find the minimum point on this. So we just did that, and we found the vertex to be 2.5 and -2.25. Okay, so let's go ahead and plot that here. So we have 1, 2, 2.5, and then down 1, 2, and about 1/4. So maybe about there. Okay, and again, it doesn't have to be perfect. I'm actually going to use red instead. Okay, so that is our vertex. And yeah, so let's go down to the y-intercept. Just from looking at our quadratic, I know that the y-intercept is going to be +4. Okay, so I'm going to go 1, 2, 3, 4 up here. Okay, now to find the x-intercepts, we need to do a little bit of playing around with our calculator, right? So if you do the second trace feature, you can find the zeros in there. That is what we did, and we found the x-intercepts. So our y-intercept was 0 and 4. And then our x-intercepts, we had 1 and 0, and also 4 and 0. Okay, so let's go ahead and plot those as well. So 1 and 0, and 1, 2, 3, 4 and 0. Okay, so those are our points of interest so far. And that's really all we need to sketch this graph. Okay, so now we're just going to connect the points. The coefficient is positive. Okay, so it's going to open up. It's a happy parabola. And it's going to look something like that. Okay, so our vertex is that a maximum point or a minimum point? Minimum, right? Yeah, very good. Okay, because every value in that function only gets larger from there on. Okay, so it is a minimum, not a maximum, and our axis of symmetry. Okay, this is going to be the x coordinate of the vertex. Okay, so remember we go x and then y. So our axis of symmetry is going to be x is equal to 2.5. Okay, and we can go ahead and draw that in here too. That is our axis of symmetry.
Like for a test, how close would it have to be, like within point?
Oh, like if I saw that you calculated it and we just had like a value off by like 0.1, or even if it's off by like, you know, like a small bit, that's totally fine with me. I'm not really picky with numbers. I'm more concerned with like the actual process itself. Okay, so if we're off by like a few decimal points, don't sweat it at all. Okay, please don't sweat that. No, as long as you know like how to find your x-intercepts and your vertex and all that stuff, that's totally fine with me. If you're off by like 0.1 or 0.2, no worries. If you said your vertex was like 4.5 and negative 2.25, okay, different ballpark, right? But yeah, if you're off by like just a little bit, no worries at all, okay? Okay, more practice. So just try this one on your own, and you can graph that. All right, so from this graph, just looking at the equation, we can find out a couple things. So looking at the coefficient in front of the x squared, it's negative, so
it's facing down.
It's facing down. It's a sad parabola, right? And from this as well, we can tell that our y-intercept has a value of 2, right? So we have our y-intercept value of 0 and 2.
Yeah.
Okay. So then if we graph this, we will get a few points of interest. So using your calculator, you can find the vertex. So when I calculated it, I got negative 2.3 and
18.1.
Yeah, 18.3, 18.1. Yeah, like in that ballpark, right? We're not going to get like the exact same values always, and that's okay. Okay, so let's plot these points of interest. So our y-intercept is 0 and 2, so that's going to be there. Our vertex is negative 2.3, so each of these spots is going to be 2 for my scale. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so we have 10, 12, 14, 16, 18.3, so something about there. Okay. Our x-intercepts, so when I calculated these, I got negative 4.8 and 0. Similar to that?
Yeah, 4.6 and 1.8. Oh wait.
Yep. Perfect.
How did you get 0 for?
So on our x-intercepts, our y value is always going to be 0, right?
Yeah, I don't know how I.
Did you just mix them up?
How did I get that one?
Come on.
What did you get on yours, Brody? It's all the same.
Oh,
Or like,
I got 5.
okay, yeah, that's fine. Yep.
yeah, I got 4.6 to 1.8. I don't know. That doesn't make sense.
Okay, yeah. So make sure we're careful, and after we use our calculators to find those intercepts, make sure we look at them and they make sense, right? Like on our intercepts, so if it's a y-intercept, the x value will be 0 all the time. Okay? On the x-intercept, our y value will be 0 every time. Okay, so if you get anything different than that, do it again.
Yeah, because like I tried moving it to wherever and it just gave me 4.6 and 4.7.
Okay. Yeah, and yeah, so we just have to think about our answers that we get from our calculator, right? Our calculators are smart, but we need to be smarter than the calculator. Okay? So the other x-intercept that I got was 0.13 and 0. Okay, similar about that?
Yeah.
You just put 0, yeah, that's fine too. Yeah, if you just want to be like, that's 5 and 0, that's totally fine with me, okay? So 1, 2, 3, 4, 5, so just put it right around there. And our other one is pretty much like right on that axis, okay? So, if I know, so if it's a sad parabola and it's facing down, is my vertex going to be a maximum or a minimum?
It's going to be a maximum.
Yeah, absolutely, right? Because everything is going to get smaller than that, okay? And if I know my vertex is negative 2.3 and 18.3, what must my axis of symmetry be? 2.3.
2.3 to 18.1.
Excellent. And negative 2.3,
Yeah.
right? Yeah, perfect. So x is equal to negative 2.3. And it's just the x value, right?
Yeah.
Just the x value, okay? Yeah, so let's go ahead and sketch our graph now. So it's a sad parabola. So it's facing down. So it's going to look something like that. We'll work on our parabola drawing skills, but that looks good, okay? And that's why you want to draw your points of interest, because then you're just like, yeah, it follows all of those points of interest. I gotta work on that, okay? And then our axis of symmetry will go right down the middle at negative 2.3. Okay? We're all good there?
Yeah, yeah.
Excellent. Okay. So there are 2 more characteristics that we need to talk about. So domain and range. Okay. So domain, so make sure you guys write these down. If you don't, yeah, you need to write these down. So domain is the possible x values of a graph. So that's gonna go left to right. Okay, and range is the possible y values of a graph. Okay, so how high and how low does it go? Okay, my best way that I remember how to not get domain and range mixed up, I put the domain and range in alphabetical order. Okay, just like the x and the y, okay? So domain is associated with the x. Actually, maybe I should draw that in blue. So domain is associated with the x coordinate, and the range is going to be associated with the y coordinate, okay? The way that I remember it, x and then y, that's alphabetical order, right? It goes x and then y, and same with D and R. So doctor,
Yeah.
x and y, that's how I remember that. So D comes before range, so domain is associated with x, and range comes after domain, so it's associated with y. Okay, that's how I remember that. Just the order of the alphabet. Okay, so yeah. That's all I have to say about that. So the range, that is going to depend on the A of a graph. Okay, whether it opens up or opens down. This would be a max, and this is going to be a minimum. Okay? Questions? Okay, so we're going to look at a few quadratics and go over the domain range.
Can I quickly run to the washroom?
Yep, of course. Yep. Okay, so this guy right here. So domain is associated with the x and the y, right? So, and remember, these go on forever, okay? So, the domain, the x coordinates, where on, like, in respect to the x-axis does this graph exist? Where on the x-axis does this function exist? And remember, these go on forever and ever and ever and ever. Is it limited, or will it just go on forever? Yeah, right? The domain of this function and any other quadratic function is always the set of real numbers. Okay, so the way we write that, so the domain of this function, so x, so remember domain is associated with the x coordinates, right? So x is a set of the real numbers. XER. X is a set of the real numbers, meaning that this domain will go on forever. Okay? In both directions. These are infinite. Okay? Domain is a set of the real numbers. Okay?
Are these all kind of infinite?
The domains?
Like all of these?
Absolutely. Totally.
Is there any like one that wouldn't be?
Nope. Not a quadratic. Okay? Quadratic's domain is always a set of the real numbers. Okay? Really good insight there. That's excellent. Okay? What about our range? Our range is not necessarily the same. Remember, so range is our y coordinates of the graph, right? So, what do we call this point right here?
The vertex or the axis of symmetry or whatever.
Yeah, right? For sure. So let's just talk about the vertex right now. Okay? So, the range of this function, does it exist below the vertex? Is there any graph below our vertex?
Probably, but we don't need it.
Do you see any part of the graph below the vertex?
Like 3 columns, but that's pretty much it.
Right. So this function ends right there. Okay? So anything below it, the range of that function does not exist. Okay? So let's find the vertex though. So 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4. So this point is -4 and -7, right? X is over -4 to the left, and it's down -7 to the right. So if everything is above the y, we'll say that the range, so range is greater than, do they say, I just don't remember if they say y. Okay, yeah, okay. So y is greater than or equal to -7. That is the range of this function, okay? It is either greater than or equal to -7. Below it, it does not exist. Question?
Well, I'm just kind of confused with like, what? Like, the range, like, what do you mean?
So the range is just like where we see it on the graph, where it exists,
Okay.
where it is, okay? So let's just jump to the second one right now, okay? And this might help a little bit, okay? So let's find the coordinates of our vertex, so which is right here. So 1, 2, 3, 4, 5, 6. So 6 in the x direction and 1, 2 in the y direction, right? So as we mentioned and as you noticed, it always goes horizontally forever. The domain is infinite, right? Because they will just go on forever, okay? The range is not, though, right? So this is our vertex, right? Is there any graph below the vertex?
Decent amount, but it wouldn't matter.
Sorry, I don't mean graph. I mean the function. Let's just look at this line. Okay, we're only concerned about the line. Forget, yeah,
Oh,
this function. Okay, we're just looking at the function. So this line here. Okay, is there anything below y is equal to 2?
No.
No, it's all above that point, right? So therefore, our range is going to be, so y is going to be greater than or equal to that 2. Right? There's nothing below it, right? So it just doesn't exist. But above 2, that is where our graph, or our function exists.
when you put like y is greater than 2, would that just mean like, and then y is just,
Yeah, so y,
About disconnect.
this is y is equal to 2 right here.
okay,
That
so
blue
where's
line
the
there,
vertex?
this is y is equal to -7.
Oh, okay, I understand that.
Okay? Yeah. So these graphs only exist above those 2 points of the range, right? The domain extends forever. Okay? Yeah, okay, so we just got a couple left to do. So try these, oops. Let's try these last two on your own, please. Okay, so the domain of a quadratic always is what?
XER.
XER. So X is a set of the real numbers, okay? So it will go on forever in either direction.
Can I just start doing this?
Yeah, sure. Go on. Okay. And then what about our range? So what is our vertex?
On -1, 7.
Yeah, sure. -1 and 7. Okay. So is our graph going to be present above 7 or below 7?
Below.
Below 7, right? So our range is going to be what?
Y is greater
Y is
than
greater.
7.
Greater than?
No, Y is less than 7. 'Cause
Less.
No matter what, it's less than 7.
Yeah, y is less than or equal to 7. Okay? It's less than, right? It doesn't get bigger than 7, it is less than, right? So this is a maximum point, right? Okay, so this one over here, we have a vertex at 1, 2, 3, 4, 5,
Yeah, 5.
like 5 and -1. Right? So our domain is always going to be XER for a quadratic. And our range is our graph above or below this point here, below our vertex.
Oh, below.
Below, right? So this is going to be a maximum.
Yeah.
So what's our range going to be?
Y is less than -1.
Less than or equal to
Less than or
-1,
equal to -1.
right? Yeah. Good. Okay. Lastly, we'll just finish up with these notes here. Okay, so what do we notice about the domain for every quadratic? Domain is always a set of real numbers. Okay, so domain, remember this is your x values. Okay, what do we notice about the range? Well, it is either greater than or less than the y value of the vertex depending if it is a happy parabola or if it is a sad parabola. Okay? So depending on the A value, right? What does its value have to do with the vertex and whether it represents a maximum or minimum? So if it is positive, if it's a happy parabola, it is a minimum. If it's a sad parabola, it is a maximum. So remember, if A is positive, if A is negative, it is a max. Okay?